Hey everyone, before we dive into the technicalities of Spark, let me ask you this. Imagine if every time you type a command in Excel, it recalculated the entire sheet instantly, even if you are not ready for the final result. That would be insufficient, right? You might still be adjusting your formulas or filtering the rows. This is exactly the problem Spark avoids. Instead of running every step the moment you type it, Spark waits, builds a plan, and executes everything in one go when you actually need the result. This smart approach is known as lazy evaluation. So, we will learn what lazy evaluation is, why Spark uses it, the difference between transformation and actions, and finally, we will walk through a code example and DAG visualization to see how it works in practice. So, let's start by defining what lazy evaluation in PySpark actually means. Lazy evaluation means Spark does not execute the transformation immediately. Instead, it builds the logical plan of operation called directed acyclic graph that we commonly known as DAG. The DAG contains all the steps Spark need to perform, but none are executed until an action like collect, count, show is called. Think of it like writing a recipe. You can write all the steps in order, like chop onions, boil the rice, fry the vegetable. But the actual cooking only starts when you are ready to eat. Spark behaves the same way. Now that we understand what lazy evaluation is, the real question is why did Spark Creator choose to design it? Let's explore the benefits, starting with optimization. Spark analyzes the entire chain of transformation. This allows us to rearrange, combine, and simplify the operation before the execution. Example, if you select only two columns after filtering, Spark won't load unnecessary columns at all. Next is resource efficiency. Before transformation aren't executed immediately, Spark avoids wasting CPU and memory on immediate result that might not be even be needed. Data is only loaded and processed only when an action demands it. Next is fault tolerance. Spark maintains a lineage graph. If a node in the cluster fails, Spark can recompute the lost data from the DAG instead of starting everything from the scratch. Next is flexibility. Developers can chain together multiple transformation. Computation only starts when we say, now I want the result. This makes the iterative development and debugging much easier. So, lazy evaluation is not just about delaying the work, it's about doing the work smartly with fewer resources while ensuring the reliability. So, lazy evaluation is tightly connected to the difference between transformation and action. Let's clearly separate the two. Transformation are lazy operation. For example, filter, map, group by, join. They only define the logic of what we want. Spark just records them in the DAG. No execution happens yet. Whereas actions are the triggers. Example, collect, count, show, write. When you call an action, Spark looks at the DAG of transformation, optimizes it, and executes everything on the cluster. Actions return either the data to the driver program or results are saved to storage. Let's now look at the practical example to see how lazy evaluation works in PySpark. Pay attention to what Spark is doing at each step and what is not doing yet. So, in the first line, we are creating a data frame from the CSV file. At this stage, Spark does not read the entire file into memory. Instead, it only stores the metadata like the schema, column names, and the file path. The actual rows of data are still untouched. In next line, we are applying the filter. It keeps only the rows where the age column is greater than 30. But remember, transformation are lazy. Spark does not scan the data yet. It just adds this step to its internal DAG. In the next line, we are applying another transformation, which is selecting only the column name and city. Again, no data is processed yet. Simply Spark extends the DAG. Finally, we call the action show. This is the trigger point. Now, Spark says, okay, I need the actual result to display. It looks at the DAG we built, read the CSV, filter the age greater than 30, and select the column, and finally show the result. Spark then optimize the entire sequence, for example, skipping the unneeded columns while scanning the file. Only now does Spark distribute the work across the cluster and execute the job. And that's the power of lazy evaluation. Spark waits, plans smartly, and executes only when it's truly needed.